Yeah, I relate refactoring to something that I noticed that many people, many programmers, but also people in general have. Uh, it's easier for them to understand the static view of a system, be it social
Yeah,
systems or computer systems or code systems, whatever. And it's harder to think in terms of dynamics. And refactoring is that thing that is dynamic, that says instead of
yeah,
writing a static thing that is what I imagine, what I do is start by writing something and then kind of extract and
yeah,
transform until I get to the desired
yeah,
result. And this seems to be kind
yeah.
of a general problem of thinking, which I don't know how to overcome, but it seems to be related to static and dynamic.
I think you're right, and the idea of something as a given. Once, if somebody gives me a piece of code, then that's it, and then my goal is to add, you know, rather than shape it through my understanding, and to treat the process of understanding as an interactive one. That, and I think the first time I came across this kind of style of thinking was actually pre-XP. So yeah, I come across evolutionary design, in the early 90s, rapid application development, all these things. Yeah, this is all good, but what does that look like in practice? And what does it look like at the detail level? And I then read Kent Beck's Smalltalk Best Practice Patterns book. That was published 97, I think. And I read that. I certainly read it in 97. It might have been published in 96, but I read it and he doesn't talk about XP in that. He doesn't talk about really unit tests or anything like that. It really is just, here's some practices in Smalltalk. And then he has a section right at the back where he talks about his approach to code. And I suddenly had a huge moment of resonance, because he says, well, when he's dealing with a piece of code, he starts, as it were, shaping it. It's a very physical metaphor. It's just like, I'm trying to get involved with it. And I do that by changing it. It's more an act of kind of, cooking can be appreciated from the outside, but you've got to kind of get in there with the meal. You take somebody's recipe and you go, oh, this needs more garlic, or maybe, and in other words, you learn by interacting with it rather than merely observing it and treating it as a passive given, which is interesting, because that is, I think, where we need to communicate and not just say, hey, evolutionary design, or we build stuff and extract it. It's that idea of constantly shaping as you go through, and to tell people that's normal, that's actually, it's okay, they're allowed to do that, and that's actually how they should be thinking about it. That perpetual refinement. I think there's something there, and as you say, it's dynamics. It's the dynamics of what I do. It's the, how do I do this? It's not just keystrokes. There's something else going on here, and it's an interactive, malleable thought. It's like working with clay or something like that. I say that, but I can't remember the last time I touched clay. It was probably 27 years ago.
And I wonder if these ideas came for Smalltalk because Smalltalk had that idea of kind of a universe that contains objects, and that you kind of play with those and shape them.
Yeah. I think the closed universe, I think there's two things there. Is one of the nature of the language, highly dynamic, and there's a plasticity to and its integration with the environment. And again, people like Alan Kay would cite that they got that from Lisp and just took the idea further. So if you like, there's that kind of plasticity. It's changeable. It's not fixed. It's not built in stone. And so I think that was one of those ideas, and there's a consistent metaphor for that. But also, it's a closed universe that actually helps quite a lot. It turns out when you publish code and other people depend on it, yeah, you have some other things. And when you want your system to talk to the operating system, and the world I come from is more embedded and real time, it's just like, yeah, you can't say closed universe. It doesn't work anymore. But at the same time, I also realized there was a resonance with other areas when people talked about a much more, I don't know, dynamic approach to development. The kind of Unix, the original C in Unix tradition, that the shell was this kind of environment. The history of Unix shells is one of immense expressiveness. It's no longer confined to Unix. I look at something like Microsoft's PowerShell, massively underrated tool. It's a really good piece of design. The shell thinking, that idea of like, hey, guess what? It's not just for listing your directories. Whereas previously shells have been just job command languages or just very, very rudimentary. And that idea that everything was available and that your development tools were on hand. That you know, it was this kind of idea of this round trip approach. And so I think if it hadn't come out of Smalltalk, I don't think it would have come out of the C++ community. I don't think it would have come out, actually, funny enough, of the Java community as it was. Had a different timeline been taken, I think it would have come out of kind of like the Unix world. You know, if we tinkered with history and messed with the timeline, I think that when we start looking back at the history and what was created there, it's like, actually, yeah, they had a lot of the right ingredients in place and were saying some of the same things at times. Perhaps it was not as strong and emphatic as it came from the Smalltalk community, but they were. I think that would have been an alternative origin story if we ran the timeline differently.
Yeah, that's very interesting. So if we move to code paradigms, you have a few talks that I found fascinating about the different paradigms of code and how they influence actually code that we write today sometimes without even realizing that we have this influence. I've also looked through, I like to look at the history of programming languages and how things got developed and so on. So it's very interesting to see how these things are actually recycled in time. So it's kind of like a spiral of things that keep coming back. And now functional programming is making a comeback and a lot of other things. But what do you think about the current state, or what do you see of the current state of using paradigms like structured, object-oriented, functional? How did they shift, or where are we?
I think that it's kind of an interesting one, because I think that as I was just having an email exchange, and I had a call last week, funnily enough, where we ended up talking paradigms. And one of the points that I often make is that people have a very simple, you know, most developers I encounter have a very simple view of paradigms. You know, they think, oh, there's 2 or 3 paradigms. You know, there's object, there's procedural, and there's functional. And in their minds, they often have a sharp boundary between each paradigm. In their heads, just like, oh, this belongs in this paradigm. Rather than appreciating that a paradigm is more like a territory. And there are parts of the territory that blur, you know, you know, unless somebody draws a line across it, you don't know that you've crossed a border. The borders are abstract. Borders are a human thing. We make them up. And I see this a lot when people say, oh, look, you know, this language now has lambdas. It's got functional features. And I'm kind of always thinking, like, actually, if you look at the history, you wouldn't say that. Lambdas are not a functional idea. That they're a programming idea that happen to be more common in functional languages. But the idea of passing a piece of code around, that's not a functional idea. We were just talking about Smalltalk. It's just like, so Smalltalk got this idea from Lisp. And if you like, what is a lambda? It's a piece of code. What, you mean code is an object? Yes. So in other words, lambdas are an object-oriented idea. So I often joke to people when they think, oh yeah, I'm using Java 8 and I'm getting into functional programming. It's like, no, you're not. You're using Java 8 or Java 8 after. You're doing object-oriented programming. You can't do functional programming in Java. Try writing a function without surrounding it with a class. The dominant paradigm is still object orientation. You can do things that feel a little more functional. Just if I'm speaking English and I borrow in some words from other languages, I'm not speaking those languages, I'm still speaking English. And it may change the way I express English. English has evolved over 1,000 years. Its word ordering has changed as for that, but it's still kind of English, and Java is still Java. You've done lambdas, great. So I joke to people, in 2014, Java became object-oriented. I actually, because I gave a talk in 2003 where I got up in front of a Java audience and said, Java's not an object-oriented language, or rather, it's not a fully object-oriented language. Here's a bunch of things I can't treat as objects. I can't treat an int as an object. I can't treat a method as an object. I can't treat a block of code as an object. And I said, that's what object-oriented means. A bit partially object-oriented or hugely influenced by object orientation, yeah. So what happened in 2014 is that Java became object-oriented. More fully object-oriented. It allowed me to treat a chunk of code as something I could pass around, just like I could with everything else. So in that sense, but then we look at procedural languages, and the idea of passing a block of code around was actually part of the original story in the 1960s. And actually that gave rise to object orientation. A block of code had state and it had procedures. And what if you could pass a block around? Oh, that's pretty crazy. What if that block stayed around? It would have state and it would have behavior. This sounds really familiar. And I can pass. So you start realizing that these sharp distinctions are not really as sharp as we thought they were. And when we look closer, we realize, object-oriented, there's Java object-oriented. You know what? That looks completely different to Ruby object-oriented. And yet we call them the same paradigm. And working in a dynamic language like Ruby or Python feels, I'd say the bigger difference between working in Ruby and Python versus working in Java and C# is not the paradigm, as we like to call it, it's the dynamicness of the language. Actually, the dynamic versus static is a far bigger influence on what you program. So it's also the fact that we've been, as it were, talking about our languages the wrong way. We've been distracted by one aspect, which is an important aspect, I will say, but we've been distracted by it and not been very good at it. There's more than one kind of object orientation. There's more than one kind of functional. A lot of things that people call functional used to be considered separate from functional or part of logic programming. So data flow programming was considered a separate approach. And now these days, everybody puts it under functional. A lot of the logic programming stuff, things like set comprehensions, list comprehensions, stuff like that, that's kind of logic programming originally. But we kind of sneak that one in there and say it's functional. So every paradigm redraws its boundaries to make itself look bigger. This is just humans, okay? So the thing is, what we see is that the paradigm landscape is both more interesting and less interesting than we thought it was. It's more interesting because it turns out there's huge overlap and you gradually shift. Sometimes you can pick something and go, oh, Haskell, very, very functional. Smalltalk, very, very object-oriented. But where does it cross from one thing into the next? Is it that easy? So maybe the way we should look at the landscape is to think of it like a mixing desk rather than, there are I've heard people say there are 3 paradigms. No, there's you go and look at a book on paradigms, there's, 20, 30, 40, depending on how you want to slice it. There's loads. And they subdivide some of the things that we consider to be a paradigm. They subdivide it and they show you the distinctions. Procedural programming in Fortran is fundamentally different to procedural programming in C, having been paid to do both. They are really different, and yet they get called procedural. And they are different again to COBOL, which fortunately I was never paid to do, but I worked alongside COBOL programmers. That's called procedural as well. And it makes Fortran look so close to C. On a cosmic scale, COBOL is somewhere over here, and Fortran and C are right by each other, and yet these are still called one paradigm. So we fail to appreciate the breadth and diversity within the paradigms. But if we think of it like a mixing desk, that's much more interesting. You kind of fade up or down, it's just like, oh, okay, what are we going to do about functional composition? Well, that one's going to be kind of low in this paradigm, or it's high in this paradigm. What about state mutability? That's low here, high here. Or what about data abstraction? That's low here, high here. And so if you look at it like that, it starts making more sense of this diversity. But you've also got to include the other stuff, the dynamics and the environments the languages come in. So I think for me, I think that what we are entering is an era where we're not going to end up with a dominant paradigm. I was asked this, I think it was, let me think, I did a talk with Frank Bushman at the OOP conference in Munich in 2017, 50 years after Simula 67, the original kind of OO language. And one of the questions we were asked was, do you think that functional programming will become as popular or more popular than object-oriented programming? And I kind of said there's kind of like 2 parts. I said, no, but I don't think anything will. I think the idea of a dominant universal paradigm, I think we had that, it's dead. And secondly, the most dominant paradigm today is still procedural. It's actually, a lot of people are using object-oriented programming languages, but actually the dominant paradigm is procedural. If I look at a lot of Python code, it's predominantly procedural. Script code is predominantly procedural. People rave at me about Golang. There's some really nice stuff there, but it's procedural. That is a procedural language. You go back and you look at all the design ideas. That is a procedural language. Plain and simple. That's what its backbone is. That's what its defining characteristic is. It's got some nice data abstraction ideas. It's got some good concurrency ideas. But again, it's predominantly procedural, and a lot of those ideas came from a procedural universe. So even languages people are advocating now are procedural is still there, whether people mean to or not. You look at a lot of Java programming, and it's inappropriately procedural rather than good procedural. So one could say object orientation never reached the dominant paradigm. It just happened to be the dominant paradigm for language designers, but for programmers, probably I'd still say procedural is their default.
Yeah, and an interesting question that comes to my mind listening to you talking about this is about what would be these characteristics, if you were to pick these characteristics for your favorite programming language, which would be those? And I can give you my to allow you to think a bit.
Start, because I don't think I have an answer to this one.
So it's interesting because I like the strong constness, immutability stuff that you have in C++, and you cannot find in many other things. You write const on something, you know it will be const. Well, unless you are doing something really weird, but then you can always shoot yourself in the foot if you want to. Then I like things like types that are not as strong, or at least that I don't have to write specifically, that are more like inferred rather than me trying to figure out, oh, what type should I write here. And I like this possibility of composing functions and passing things around. And I like the orientation towards objects rather than classes. I'm not so interested in the classes anymore and the relationship between classes, but more in the objects and relationship between objects. And that's so perhaps you can start from some of these, agree or disagree.
I think there's some things that I would say, rather than sort of things that I think one of the things that I've really learned, I actually, funny enough, this one doesn't come through programming languages, or rather it's an observation I've taken back into programming languages, but comes from elsewhere, kind of behavioral economics and so on, is the power of defaults. Which way do our defaults go? I think this is an interesting one, because there is the idea, for example, in something like C++, as its tradition, it has a history that takes it to this point. But by default, you mentioned constness. By default, things are mutable. You have to ask for things to, the default is there. You have to ask for things to be const, which is why people struggle to make things const consistently. So the point here is, why don't we change the defaults? If we had our time again, a number of languages have moved this in that way. They have nudged it over. You kind of like or made it just easy. So Kotlin makes making something immutable easier. Scala makes using something immutable easier. Rust does the same thing. Here, in other words, what they do is, it's not that they disallow the mutability. What they do is they just say, either here by default it is immutable. If you want to change it, you have to ask for it. You need an extra keyword if you want to change it, or it's as the effort in declaring something or describing something as immutable and mutable is identical. So there's no distinction between the two in terms of effort. So there is no default. And so for me, I would urge language designers to think along those lines in future, that, make it easier to do the immutable thing than the mutable thing. Even if you're not being paradigm pure and saying everything must be immutable, and we're going to throw, some kind of fiction in to deal with the mutability of the world. We'll throw in monads, we'll throw in some kind of abstracted actor model or one-way data flow to kind of basically say, we're pure, but there's a thing over here that's impure, but we don't look at that or talk about it, so we hide it away. Before we're even doing that, even just saying you're creating a general purpose language, maybe it's not paradigm strong, but I would nudge the defaults. That would be one thing I'd do. I would also invite people to really go back to block structure, really embrace the idea of block structure, fully understand it. A block is a thing. A block can have code and it can have data, and you can treat code as data. There's a universality, and I can be able to pass a block around as a chunk of stuff. That idea is, I think, incredibly powerful. And some languages do it better than others. Some kind of fake it. I can now do kind of local methods in C#, and I can there's a bunch of stuff that I can start doing where I've got some kind of nesting concept. But the nesting, that recursive whole part structure, is very powerful. But you mentioned something else there I think was interesting: composability. We got distracted. People talked about reuse. That's not interesting. Code reuse is actually not as interesting as people made it out to be. Most of what makes code reuse possible is not paradigm, but culture. If you say, hey, Kevlin, here's a piece of reusable code, and I go and look at it, it's just, well, okay, but maybe from you. It's just, oh, Alex wrote this. This is fine. I know Alex, he respects all the good practices and all the rest of it. But at the same time, what's going to make that, we actually discover, if we look at the history of reuse, actually look at the history of open source. Open source was the thing that made reuse the thing that happened. It wasn't a paradigm of coding. It was a system of culture and trust. It was the documentation. It was the test. It was surrounding a body of code with a community that is living and responsive. That's going to make me want to use a piece of code. Some piece of code that is just sitting there without documentation, without kind of any quality assurance, without any reason for me to believe it's a good idea. I'm not going to use that just because somebody said it's reusable. That's a distraction. So the whole objects thing, and even without the objects, the whole reuse thing is a distraction. Reuse is a very different kind of thing to what people were talking about. What they're actually talking about is use. And that a lot of that is that there's a cultural concept there. But composability, now you can put your finger on that. And all the original objects stuff, and a lot of small talk community were about composability, but that got swept up in the language of reuse. And that was the wrong term to be using. Composability, now we get that when now that people have a renewed interest in functional programming, that is a domain and a sort of paradigm set that is relatively unaffected by that reuse fad. So it has a cleaner vocabulary, one that is actually probably more consistent. Composability, that idea of composability, I think that is something I would really value. But beyond that, I struggle with saying what would be my best language, because I think that's kind of like, what music do you like to listen to? It's like, honestly, what was, in the last week, I have listened to punk, new metal, 70s rock, ambient. Which one is my favorite? Honestly, some 90s pop as well. Yeah, just for some good fun and a bit of grunge. And I'm thinking right across these, and it's like, they're all good. 70s soul. I was listening to some of that. And so do I want one, the perfect paradigm for programming is a bit like often, what is the perfect genre of music? And honestly, it's not I like sometimes things to have a little separateness. Maybe I want the language that is totally dynamically typed, and I want the language that is totally statically typed, but I'm not going to have those in the same language. So I'm going to kind of unask that question, step back from it a little bit.
All right. So the one curiosity that I have is you're doing a lot of talks, and you're doing a lot of different talks, which is also kind of what I'm doing as well. I don't really like to repeat the same talk. I find it kind of boring to do it again and again. And so this is good and bad. It's good because it keeps me working on new talks and thinking about new stuff, but it's also bad because you don't get so much so many people familiarized with one talk and getting there. But what I wanted to ask you, all your talks are really good. And one thing that I notice is that they tend to be also non-linear, which is kind of difficult to do for talks. So how do you do that? How do you build them?
Oh, that's a good question. So I take a slightly different path from, I do redo my talks, but they're never the same twice. Sometimes I think there's an idea, particularly with a new talk. When a talk is new, I need to learn what the talk is about. I mean, you might say, well, surely you know what it's about. You put the slides together. It's like, yeah, that's the first draft. There's this idea from writing that writers, the first draft is you telling yourself the story. The second draft is where you try and tell somebody else that story. You learn about it. But I've also gone back to things that I have written, both fiction and non-fiction, years later, and suddenly realize, oh, there's a thing in there I did not see, and you make a connection you didn't before. So for me, sometimes I will say this is a new talk, and I will target it at a number of conferences, and it means I've got it on the shelf. I can just pull it down and I can use it. But what actually happens is I give a different version every time. There's bits that are the same, but I then adapt it. I see what works, what doesn't. Sometimes I'm learning, what am I really talking about here? I put a bunch of stuff in, but now it turns out that now I come to deliver it, there is a thread here that is more obvious, and some of these other things perhaps I should remove, but there's an area here I want to talk about more. And that also starts hinting at this idea that when I say I write a new talk, I don't. All my talks are remixes. They each have, it's like a spider plant. Sometimes they are, I will start a talk and say, I will start putting together a talk and say, well, this talk is a new talk. It's a thing I want to talk about, but it also bears some similarity to an existing talk. So I would use some of the DNA from that. But in other cases, if you deliver a talk, or particularly actually some of this stuff comes out of doing workshops and courses, you suddenly realize there's one or two slides there that you spent a lot of time on, or people asked you about, and you think, I should expand that. It's like double click on this, and you suddenly realize there's a whole universe here, and that gives rise to a new talk. It gives birth to this new talk. It's just like, well, it came from this, but eventually it becomes something that seems quite different. So that's part of the non-linearity, because you start realizing, you start taking detours, and you start accommodating your own non-linearity. But I think that the deeper essence there is a kind of a storytelling thing, and that I think is a thing that I have changed over time. If I look back at talks that I was doing 20 years ago, they tended to follow a much more natural top-down structure. I would have specific sections and so on. You'd follow that kind of like bullet point and burrow into each section and go through. But I also started realizing that I was giving a different talk to the one that was on the slides. And I don't know, it was about 12, 13, 14 years ago, I started realizing, you know what? These slides just do not fit what I'm doing. I'm saying something completely different, and people are enjoying that talk. But what I've got up here is I'm stuck in a kind of like almost a course delivery style, which is part of my background. So, I suddenly thought I need to decouple that. If I've got 1 hour or 45 minutes or something, you're not going to be able to take something and put it straight into somebody else's head wholesale. You can take one idea or a set of little ideas, and you can get somebody interested in it. Maybe you can give them one thing that they can walk away with, but you're not going to teach everything and show everything. So maybe treat it as a journey, rather than as a meandering journey. Not that's going to go in a straight line. Sometimes you can do that. You can build up, but I found that what I tend to do is try and find the way back home, so that in the close there is some kind of like, reflection of the beginning, or we've taken a tour of ideas, whether it is broadly in the agile space or more specifically in the code space, with a paradigm or with testing or something like that. And we've taken a journey, and we've somehow ended up really understanding what it is that we set out to do. At the beginning, we actually now understand what we were talking about. So I think for me, what changed is my conventional view, my more hierarchical view. I realized maybe it's not right for things that are of the order of tens of minutes. Maybe you need to offer people a journey, a plot, but plots that are straight lines are quite boring. We like plots that have kinks and deviations and backstories and things like that. And so that's why I think there's a crossover with what I started learning in writing, but also prepared me for that. It was that idea of like, actually, what makes this interesting is there is a little journey here. It's not just a straight line from A to B. That's a 5-minute talk. That's your lightning talk. If you tell the full version, maybe it's 45 minutes long, and it goes via a number of other considerations, and you bring people in from different points of view. So it grows. That's the way I would look at it. Is the way that my talks grow is a growing process. It's not a construction process. I think would be the best way of looking at it.
Yeah, so it sounds like more that you are pulling out from a web of ideas and kind of expand some of them, and so.
Yes, yeah. In fact, you said it better than me. Everybody, what Alex just said. That's you're drawing in. There's this whole space of your thoughts, and then you just pull something out. There's this web, and then that becomes a talk, and maybe the bit next to it becomes a different talk, or maybe you don't realize the connection, and another day you do. You go, oh my goodness, I've been talking as if these are two separate concepts, but they're actually one, and that in itself gives you an insight as to what else might be helpful for people. But also really interesting is when people, if you do give people these little journeys, they come up to you afterwards and go, that was really interesting. It made me think of, and you go, I never thought about it like that. So they give you something back and you go away thinking, you know what? And maybe a year later a new talk idea pops out, that's a really interesting spin. So yeah.
Yeah, and by the way, I advise everybody to search YouTube for Kevlin Henney's talks, because they are really good. So, and it's really nice to listen to them and to watch them. Now, I wanted to ask you one thing from a very long time, but we didn't have the chance. A few years back, we met at, I think it was a conference in London, and we were on a panel, and we slightly disagreed on a topic, and that's why I would like to chat a bit about this. I know that you are talking about programming being only about details, and I come from a different perspective where I often see the programming language as a detail, because I've been learning a lot of programming languages, and I noticed that programming languages are basically rehashes of the same fundamental ideas of language design. And when I'm trying to express myself in a different programming language, is fundamentally just, it's the same ideas, but how do I write them in this language? And I think you came from a different perspective, and we didn't get to discuss a bit more about that. And I'd be curious to hear your thoughts on that.
Yeah, I think it is an interesting one. And by the way, any panel where everybody agrees with everybody else is going to be a boring panel. So necessarily, there should be some kind of alternative points of view. For me, I go back to where we started. I talked about the idea that I found a lot of the detail stuff really absolutely fascinating, partly because it offers a different way of thinking. And there is a level of truth and a level at which you can say, oh, actually, this is very similar in these programming languages. But then you start going into the programming language, and what you find is it's more than just the language. Sometimes you are tapping into a different community of developers. And culturally. So, for example, people might often say, oh, C# and Java, they are so similar as languages. That truth was a stronger truth maybe 10 years ago. They've actually taken some very different paths. But they still share, as you say, most languages are a bit of a rehash. There is a fixed set of ideas that people keep rehashing from and saying, hey, look, we've got a new programming language. And it's just like, no, you haven't. Or rather, you've got a new mix. Maybe your cocktail is new, but all the ingredients are there. In the last few years, people get incredibly excited about coroutines, which were invented in 1958 and were considered to be a standard part of the programmer's toolkit. But they just kind of faded in the 80s and 90s to the point of history. And so people are getting really excited about things like that. It's just like, yep, we've seen this before. There's nothing new here. So you've got that kind of awareness that for each generation, perhaps something is fresh. People I mentioned Go earlier on. A lot of people get really excited. Oh, channel-based programming. Yeah, that's the end of the 1970s. I was doing channel-based programming in 1991. It influenced the way that I thought about concurrency hugely. It's a really powerful paradigm. It's not a new one, though. It's very, very old. So for me, there is a certain set of ingredients that we are drawing from. So in that sense, there are relatively few new ideas in programming. And it's really a case of trying to figure out, as we were discussing before, well, what are some of the things that we could learn? Well, actually change some of the defaults in any language. Really have immutability, really, it's a good idea. We should do a lot more of that. But then people say, "Oh, but you have to change everything." Yes, we are immutable in our perspective of history as well as But there is that idea that the mix is different, the cocktail is different. That even with this relatively narrow set, each one provides you with a different thinking tool, but also access to different cultures. The C# culture, the .NET culture is very different to the Java culture. The syntax of the languages may have some similarity, but the tools, the culture, the open source communities around, even the conferences are really, really different. So that idea of that is not just a detail, you're buying into something else. There's something else, though, is that the language is also, it brings with it a set of practices, but it's also what the code is written in. And you start, for me, that idea is that in some systems, the programming language is not as significant. It is less important because it doesn't have architectural significance. In other systems, it's huge. If somebody says, "Oh, it doesn't matter what programming language it is," oh, so what? We can just change it tomorrow? No. Okay, then it does matter what programming language it is, because that tells you the developers that you can hire. It tells you the skill sets that you need. It also tells you something about the tools that you can use. If somebody says, "Could we change this easily tomorrow?" and the answer is yes, then it's not as significant. But if somebody says, "Well, actually, that would be a complete system rewrite," that's architecturally significant. You've just learned that your programming language is like the laws of physics for your system. If I work in C, then I'm not working with a garbage collector. Does having a garbage collector make a difference to how you program? Absolutely. It makes a really big difference in a lot of ways. So that's something that is profound. If I'm working in JavaScript, then I'm not working with threads. I have to express currency differently. So the whole threading discussion becomes a non-discussion, which is in one sense quite pleasant. But in other cases, it can also define something. If somebody says, "I'm doing Erlang," "Oh, could you do that in C?" It's like, no, you couldn't, because Erlang comes with this universe of support in terms of what it defines as Erlang. Erlang is just like, it's the tip of a large concept about how should we program concurrently and in a fault-tolerant fashion. So the idea is the language is not just the syntax. It brings in an architecture in many cases. Now, if somebody says, "Oh, we've got a system and it's all microservice based, and actually our microservices are microservices," they're not like tens of thousands of lines long. Everything is under 1,000 lines long. And we've got some Perl code in there, we've got some Python, that one over there, that's written in Java, and somebody wanted to use Haskell for this. And is the programming language important in that context? No. The fact that you have decomposed it into separate processes that are themselves economic in size, what you've done is you've made the programming language less important. You've made the partitioning and the connection the important characteristic. That's going to be hard to change. But now you can easily move from one language to another relatively, because it's not a big cost of change. But if somebody comes along and says, "We've got 10 million lines of C++ here," you know what? Your programming language is that's your universe. That is your physics. You don't get to change that. So I think it is more than just a detail, although in some cases it can become a detail with the right context and situation. It can be reduced in terms of its significance. So, you may disagree with that, but that's kind of that's the way that I view that, and kind of have. I guess I thought about that for a long time before I even thought about it. Was aware of that. That was that idea. And I did try to program with that idea originally of not being bound to programming language, but I found that there were so many distinctions and so many, details that made something different. When I switched languages, I could program in a common subset, but it actually worked out that it wasn't very helpful. And then I started embracing the idea of idioms and really understanding, oh, that's in this language. This is how we do it in this language. And it's so much easier. And that was just back in Fortran and C. That was a real revelation. That was a real eye-opener to me.
Well, and I actually agree with you on many things that you said, because typically when I discuss about this idea that programming languages are very similar, it's more to encourage people to experiment and try other programming languages and get out of their shell. and see that it's not such a scary world out there that you are a Java programmer and you can only be a Java programmer. It's that's the only thing. But of course, if you are talking in terms of a large system, then it can become a architecture.
I think
discuss about,
I think that distinction.
Yeah, please.
No. I think that distinction you're drawing about trying to encourage people into looking at other things, I think that's a very good way of looking at it, is to try and say, if people are hesitant to try something because that's too different, then actually say no, it isn't. I can show you the ways in which it is the same, but that's to allow you to land on your feet. That's to give you the entry level to access perhaps something that is quite different and teaches you new thinking habits and possibilities, that some of which you can actually take back to your main language, or some of which will change the way you think broadly about programming, and some of which won't. But I think that idea, I think that's very attractive, and that point, it's not that different, is actually very helpful. But for some people, they need to hear it's not that similar. Actually, you're going to learn it's a completely different universe. Some people embrace that challenge. So I think that comes down to probably mindset or attitude, or people's comfort level with change and difference.
Yeah, and honestly, to learn just a programming language at an entry level, that's fundamentally very simple. To go forward than that, it's much more difficult, because then you enter the culture, you enter the tool set, you enter all the conventions and so on. All right, so we are getting close to the end. I have one more question to you, if you have any advice for new or junior programmers, people who are starting now or who've been working only for, let's say, 3 to 5 years. There's a world out there right now with microservices, JavaScript, cloud, and so on. It can be quite confusing. It's probably more complex than what I've experienced. When I started, it was just Visual Basic and C++, I think, when I started programming. So the choice was kind of easy. So what advice would you give to somebody like that?
First thing is, this too shall pass. Whatever you're working on, it's going to look different in 5 years. You need to. Nothing that you ever learn is going to be wasted. That's one thing that I've come to believe. Everything that we learn is still useful, although it may appear differently. It's training or input to something else. Sometimes some people love the API details and the latest technology, and if you're able to keep up with that, go for it. But it's a very large and confusing universe. The thing that you may find is that beneath this strong current of rapid change, there are some really stable ideas. It's not always obvious initially what those are, but look around, just see what other people are saying. See if you can find some, a little bit of history sometimes helps. We're not very good at that in software development. But look around, and what you will discover is that, there is a level that changes very, very rapidly. We were just talking about programming languages, that actually honestly, that doesn't change very rapidly. What people are doing doesn't. The fact that we now have so many languages that are easily accessible, that has changed. So in other words, take advantage of those so that you can start seeing some of the similarities. When a new framework comes along, look at it, but do so with a critical eye. Don't just assume that it's a given. It was created by people like you, sometimes with more experience, sometimes with less experience, because they were trying to solve a problem. And perhaps they're reinventing certain wheels. What are those wheels? What do they look like? In other words, start seeing the things that are the same, because you will find that gives a kind of a sense of calm. Beneath all of the changes and all of the complexity, there are so many different things that you have to know. It's insane. I gave up pretending that I knew stuff a long time ago. It's just like, no, I'm a tourist in so many different areas. Be comfortable with that, but then start saying, these probably have ideas in common. One tool inspires another developer who creates another tool with the same ideas or in response to. So when you start seeing these, you go, oh, I understand what's going on here. You find that the new API is not as big and complex as you thought it was, because you start seeing the similar principles. The new programming paradigm is not new, and the new language is not that new, although it feels qualitatively different, like a new mix. If you are able to recognize the ingredients, you're going to be able to go, I've tasted this before, I know this idea, I've seen it, and sometimes in a very different place. So yeah, track some of the flow, but see if you can find and see something that is deeper there. But I think the other thing, actually, that's all very technical. The other thing is, honestly, in development, look after yourself. I think we have historically as a culture, we're not very good at necessarily not just taking care of one another, but actually taking care of ourselves. Self-care. We spend a lot of time. If you're in software development, you spend a lot of time in front of a screen. These days, all of us are spending even more time in front of a screen, but still relatively isolated. Look after yourself. We have these abstractions that govern us. They're deadlines. The end of a sprint, a user story, or something that needs to be delivered, and we are very unkind to ourselves without meaning to be. So I think that is the longer one, because that you will go. The biggest problem is the junior developers who never become senior developers, because they leave the industry because they're so stressed out. They feel that they feel that the world's not on their side. They feel that they suffer maybe from imposter syndrome. Don't worry, everybody else is as ignorant as you are. Just sometimes they're differently ignorant. They're ignorant about something you know about, and so people get pressured out without meaning to. So I think that the bigger message is, do look after yourself and look out for the people who are likely to help you in that.
Right. Thanks a lot, Kevlin. Do you want to share anything else before we close? Where can people find you? Is there anything interesting you're doing?
Yeah. So is there anything interesting I'm doing? Let me think. I'm doing most of what I was always doing, although I'm doing more of it online. I'm still doing conferences and talks and training, which I do online. I have not been writing as much recently. I did have some more plans for another book. I did actually publish another book recently with Trisha G. There we go. Let's see if we can bring that in there. 97 things every Java programmer should know. Yep. So that was a pandemic book. We finished that that was finished and published during that. So if you're working on the JVM, actually, even if you're not, you might find some things of interest in there. So that is the most visible thing I think I've done. Although I have plans for a couple of other things. I've been doing a little more, actually more work than I expected to be doing. So I haven't really concentrated on that. But if you find me, just Google Kevlin Henney. I have a list of my presentations on Vimeo and YouTube and InfoQ. I'm on Twitter at Kevlin Henney. I don't just retweet failure photos. Occasionally I will tweet other things as well. But I'm fairly easy to find, LinkedIn and all the rest of it. So yeah, I think that's it.
Okay, cool. Thank you, Kevlin. So
thank you.
Thank you all for joining us for this very interesting conversation. You heard a lot of useful things about paradigms and what is happening around programming languages, and what is useful for you to know as a junior programmer, or as a programmer of any age, in fact. Just to pay some dues to the algorithm, please remember to share this video if you liked it, to like it, to subscribe to the channel. And this was it for today. Until next time, remember to think, design, and work smart.